Now I mentioned two different kind of work sharing construct. One is loop, and there is support for only for loop. And I believe that you already know. If not, then I'm telling you. Do while loop can also be converted to for loop. So in case of say while loop, you have condition, and initialization is above while loop, and increment will be inside the body of the while. Okay. So if you take it out and place it properly, then you can have a for loop. So if either of them is absent, then also for loop can work. So probably you also have noticed, if not, that I can write a for loop also like for semicolon, semicolon, this one. This is also a valid for. Only two semicolons are required. Expression may or may not be there. Expression can be logical. Expression can be. And then will come the work sharing constructs. So here you see one situation where array I equals to function of array I minus 1, or array I equals to array I minus 1 plus 2 multiplied with x, something like this. The point which is needed to know is this computation depends upon the computation of array I minus 1. So until I minus 1 is computed, I cannot compute array. And if I have to wait for array I minus 1, I should not misunderstand that array I minus 1 will also depend for array I minus 2. So I cannot say that array I will go to one node, wait for array I minus 1. By that time, I can finish computation of other, say array I plus 1 or array I plus 2, because there is a dependency. In this kind of dependency, we are mostly happy. Mostly. There is one option, so that I will also discuss using introduction. We can get some advantage. Another is the situation where x equals to y plus z equals to b multiplied with c, s equals to ut plus half ft square, f equals to ma. If you follow the color, you will see among the same color there is a dependency. Across the color there is no dependency. Now red, green and blue can be placed in three different groups and there is no dependency. For that, we need to divide it. Okay. One thing I should also mention here. So when we are placing this one, as I said, that they are not dependent. And regarding the reordering of the instructions, since these two are independent, so I can take it down and take this blue up, so that same color is clustered, placed side by side. So what will be the advantage from programming point of view is that the set of blue color statements can be put inside one packet and sent to one thread. Another color will go to another thread, another through thread, another, like that way I can discuss. Okay. Oh yes, you are absolutely right. So in that case, I cannot do this one also. So f is there. So if f is here, I am writing. So this will also be blue. Thank you. Yes, it will not be red. It will be actually blue. Okay. So f is there. If this is computed earlier than this, then its value will be something. If it is computed after this one, then its value will be something. Yeah. Thank you. So in parallel for construct, so pragma will be parallel for clause and for loop is there. It should not be yes, it should be A, and it will become independent. No. So okay, so we are not doing that nuclear mechanics as per situation. So it is So you are right. Okay. So then I have to justify what is this A. Okay. So I read it half empty square because of the simplicity, but don't go by that. Now section first, because section is simple. In section, hash pragma will be sections. You start with that one, give parentheses, opening and closing brace, and inside that one, for each section, you write hash pragma will be section new line structure for each section. In our case, for hash section, there will be one hash pragma OMP section. For star, hash pragma OMP section. For double star, hash pragma OMP sections. And when there is a dependency, so when we are looking for the dependency, that dependency analysis needs to be done by us. It is not automated as of now, but if you can write, yes, there is a possibility that you can write a program. So that program will analyze that one and group it and then prepare it for the sections. So that can be done. But since we are not doing that one, as of now you can consider that is manual. You have to look at that one and you have to identify that which are independent by looking at their data dependency and accordingly you put them. Again, this private, first private, last private, reduction, no way it is possible. Private we have discussed. So while there is a local copy, shared is basically when it is being shared. But what is first private and last private? I will explain. Now single construct. Single construct is similar to the situation where one thread is in execution. Okay. Now, if I draw the diagram, so you remember the fork and join situation, right? Now you see that you have to be intelligent. That is human intelligence, not machine. Okay. You are creating 3 here, 3 are merging, then say another 4. Fork join, fork join, fork join. Because this part is sequential or serial part. So when it is serial part, so you are joining and working. Now with this one, so you remember that I mentioned in OpenMP one of the primary overhead is fork and join. Right? 3 forks, 3 joins are there. So what if I do not join it here? Because I see after some time I need 3 more threads. So what will happen? Only one thread will be in execution, rest of the thread will not do anything. Yeah, you can say that you are taking the resources and you are wasting that one. But also it is true that if very quickly I need the access of that resources, it is better not to release that one, rather hold it. And if I hold that one, then what I can do, this fork and join, I can eliminate. Right? I can eliminate that one, but in this region, I know that it will be a sequential execution. So what I will do, I will say this is one section and it is a single section. So only one thread will be executing that one. Okay? Then what I have done, I have saved some fork and join here. Right? Another point is that When I am doing this fork and join, I said everybody will finish, then it will come out of that one. Otherwise, there will be inconsistency. So as if there is a barrier at this position, everybody will be waiting for somebody. Now, instead of that one, if you write has pragma OMP single here, whoever among these four will finish first, will take up this job and finish this. And if that particular core is fast enough, there is a possibility that rest of the three core, while executing here, the fourth one will finish its job at this block, then will finish this sequential job, and everybody will reach here almost at the same time, then they will pick up this job. So overall, you will get advantage over that. Right? Similarly, I can see here it is three threads, here it is 4. But I can say that I will remove this one, I will let one to wait. Then what I will do, this one I will schedule for 3 threads. It will go to 3 cores. 1 core will be idle. It's fine. It's fine with me. Now you think one situation. Very interesting. 0, 1, 2, 3. Right? If everybody is with the same speed, 0, 1, 2, 3. If this is going to 1 and there is a dependency, so others will come here and they need to wait. You have to make sure that. Otherwise, what will happen? This 0, 2 and 3 will start executing at this position. And if there is some data here which is required at this position, there will be inconsistency. So look, these are the things you have to observe and you have to understand. It doesn't come with the syntax or programming. So what is the suggestion? What I have to do here? Let wait everybody. So once everybody will come, then proceed. But if you find there is no dependency here on the data for this particular region only, there might be some dependency here, but not here. Then do not give a wait here, rather others let flow. Then what will happen? 0, 2, 3 will be executing here. By the time it is executing, so overall your speed up will be high. Okay. So that's why you see that you have to do a program analysis, data flow analysis. And you have to make this kind of small blocks graph. And then you have to look at the syntax and implement. Because when we teach programming, we say, look at the problem, analyze the problem, design the algorithm corresponding data structure, which will take 80% of your time. Coding or implementation is as per the syntax, and that should take 10%. Rest of the 10% is on debug. Because during the program, you will make some debugging and testing. You will make something which needs to be tested. And if there is any mistake, you have to debug. Okay. Most of the time, that 80% is not used. So given a problem, you jump into start writing has include stdio.h, and that creates a lot of problem. So first problem is that these variables are not declared. So you have used those variables but not declared. Anyway, so that is what is the single construct. Pragma will be single. This private, first private, last private is also there. Now, in this case, look, thread ID 1 is basically executing this part. If I want, for some reason, that no, not 1, but thread ID 0. 0 is what? It's master. Master needs to work on it or you execute this for some reason, I will write as pragma OMP master. Okay, and that is basically the next process. It is same as the single, no wait, but only master will execute. Okay. So these are some of the library functions. So most of them we have used. Some will be used during the hands-on session. Now let us go to the form. Do you have any question up to this? Up to the sections?
In this case, can you please write according to syntax?
This one? So here the syntax will be here as pragma with the parallel sections. Okay, opening, closing. Inside that one as pragma. Then sorry, I'm taking OMP section. Okay, then opening, close. Thread 0 will be there. Then it will repeat for 1, 2, 3. That's it. Okay.
So, section and parameter is not.
Section parameter is no. This ID 1, 2, 3, 4 you need not have to worry about. So West will do that.
Number of thread equal to number of code.
Number of no. Number of thread will be based upon number of sections you are writing. Any other question? Now for loop. I like it most. I believe you will also because it's very simple. As pragma OMP parallel for number of threads you are mentioning here, and this for loop will be parallelized. Okay. Now there are several variations. Let me go to that variations. As pragma OMP parallel for num threads is fine. You know that one. So in how many threads I wish to distribute the total workload, that I will mention here in threads. Now one interesting fact is incorporated here, that is schedule. Okay, there are 4 schedules: static, dynamic, auto, and what is the other one? Right. Okay. So these 4 schedules are there. What is schedule? Again, let me explain. So actually, I prefer board over the slide. Let us, as you know, there is a for loop which iterates for 100. Okay, and you are given with say 8 cores. Now, how do you distribute the total overload? Total work. So it is the same set of instructions or statements which will be executed 100 number of times. Right? Initially, I am telling you there are 2 ways you can do that. Okay? One is very simple. Probably you can also able to guess that one. This 100 will be divided into 8 parts. And it will be integer division, of course. It will not be floating point number. So what will be the extra will go to somewhere. That way, so I will have 13 cross 4 plus 12 cross 4. That is my 100. think I'm correct, right? No. Yes. Yes. Now I divided that one. So when I divide that one, then what will happen? So let us see. So C0, C1, C2, C3, C4, C5, C6, C7. Without any bias, I am giving 13 to first 4 and 12 to next 4. And there is. So at the very beginning, I am breaking or dividing the total workload among the available cores. So the responsibility of each core will be executing that one. So that way, 13 means this will run from 0 to 12, this will run from 13 to 25, this will run from 26 to 38, like that way it will keep on running. Right? Since at the very beginning I am dividing this complete workload among the cores, so this division I am calling as a static division. Okay? Another thing is that this entire load I am not dividing. So I am giving, say initially 4 to everyone. Then how many is covered? 32. Right. Once somebody has finished, I will give another 4 to that person. Okay? Maybe this one, maybe this one. And whenever somebody will finish, I will give another 4 to that person. That is my logic. These two logic. Is it clear? In one situation, the entire thing has been divided. Entire thing has been divided at the beginning of the program execution or execution of the for loop. Program execution means execution of the for loop. Another thing is that initially I am giving a small piece, and once somebody has finished that one, I will give extra load to that particular code. Okay. The second one is called as the time, because in this case at the beginning I am giving the entire load, and the second case as the execution progresses I am giving more and more loads. So usually the situation is that in this world also who takes more responsibility, more job goes to that person.
So I understood that here you are assigning the number 4 somewhere in the code, right?
Now core number I don't have any control.
No. Like for the dynamic.
For the dynamic,
for the dynamic
you
case.
see, this will be 0 to 3, 4 to 7,
Yes.
8 to 11.
Yes, that is okay, but somewhere in the code that we have to mention that only four jobs will go to processor 1 or processor 2, something like this. Okay, so code number should be mentioned somewhere in the code, right?
Yes.
So if instead of 4 I divide this as 3, because 100 is not divisible by 3. So for the last processor, so let's say 96 go up like this. So I have the code, I have the I have mentioned 3, but I am mentioning the number 3, but I have the code portion, code race part to calculate.
No, you should not do that one. Rather, you should do this one.
That's why I.
So you will give 13. Okay, this is called as the chunk size. So how to that I was going to discuss. So when I say 13 or say 4, so how do you specify that one? Because here for loop is there. So that you will give using one thing that is called as the chunk size. This I will discuss. Not required here. I should go there first. Chunk size. So I forget to add that slide. Size. Yes, yeah. Chunk. You mentioned that chunk. Okay, the syntax is chunk. You mentioned that chunk, then it will understand. Now you should not give for the first case 12. If you give 12, then 4 will not be executed. Rest 4 will be an issue. But if you give 13, then what will happen? Everybody will try to pick 13. After finishing 12, what will happen? When it will go for that one, then so by this condition it will be restricted. Okay? So that chunk size you have to mention. So this is what I am calling as the chunk size. Now, so this slide is there, it's fine. Now going back to the previous slide that we were discussing. Can you please tell that what is the advantage and disadvantage of these two techniques, static and dynamic?
So this chunk is not.
Chunk is not clear. So this n in the for loop n is 700. So how do your program will know that C0 will be executing how many? So you mentioned that 13 is the chunk size. Then C0, its size is 0. So 0 through chunk size multiplied with 0 plus 1 minus 1. Using that, it will compute which iteration it will. Okay? Like that way, it will keep on computing. Okay? It is not you are computing, but that OpenMP compiler is computing and is assigned. You just mention this is my chunk size. But the chunk thing is clear to you, right? And two different approaches, static and dynamic. Now both have some advantage and disadvantage. In static, you see at the very beginning I am dividing that one and I am allotting, look, it is your responsibility, it is your responsibility, it is your responsibility, and the entire work is distributed, and like a manager, I go for a sick. Okay, now you work. And if I am a good manager, what I will do that I will give small job and keep vigilant. Who has finished? Oh, good boy, good girl. Some more. Now, if I give on this some more, in the first case, you see that manager do not have any role after allotting the work. In the second case, manager is allotting the work at the beginning, like static, but additionally, somebody has finished, give more job. So this way, in dynamic, there is a while, right? Checking who has finished, assign the next. Now, what is the advantage?
If the total number of job is fixed.
No, if somebody is lazy, I don't care for that time. Okay? I know he will spend the entire day with the 4 iteration and rest will finish. Say 8 core will finish 96 iterations. So there is no possibility of stucking at somewhere. Yes, of course. You can say that if it is so slow that even 4 iterations cannot do. Okay, so that's a separate issue. But if somebody is slow, so let me be slow. Others can finish the rest of the job. That is the advantage of the dynamic CPU. there is an overhead, of course, but there is also advantage. Specifically in the situation where the codes are not homogeneous in nature, or I observe some performance issue with some of the codes in my system, then it's better to go for dynamic. Or codes are not heavily loaded. Say, I am not the only person who is using this system, but somebody else is logging from somewhere, maybe my landmate or classmate, logged in and also using that system. And separately, if we are submitting the jobs, so there is no scope for time. I think in schedule it is not there, but scheduler is also play an important role in HPC systems. You have to submit jobs to scheduler. Directly you cannot submit the job. If you submit the job, then so here you are keeping a restriction that I know there are 8 cores. I will not generate more than 8 threads, and also with the good intention, your friend is also doing the same thing, and you do not know that at the same time both of you are logged in the system and submitting the job. So in total, the number of jobs will be more than 8. Okay. So in those cases, it is definitely advantageous. So that is the guide. Schedule you have to mention static, dynamic, guided, or ortho, and jump.
Sir, why didn't we told that chances is 30%? After the third core, fourth core, the C4 core, why it is not taking 30?
No, look, what will happen? So in this case, ideally, what will happen? That is for my calculation I have done. But here it will be 13, 13, 13, and rest.
It will be like. So this is how it will work. So that means C7 will be ideal for some time.
See,
C7.
will be
It will finish early. It will finish the task early and it will stay idle for some time.
yes, if it finishes. Okay. So guided is similar to dynamic, but it initially assigns instead of 4, say maximum is 30. So instead of 4, it say assigns 8 or 10, and then observe is it slow or is it fast. If it is slow, then it will not assign anything new. If it is fast, it will be 4 jobs. Okay. And it is true for us also. As a teacher or supervisor, if I see that some student is very efficient, I give more and more jobs. If I see that he or she is not that much capable, so I just try to publish in small journals. Minimum requirement: submit your job, submit your thesis. Synchronize. One we have started is user guarantees.
Even though all the codes have same capability, suppose we are submitting a computer course and there are 40 codes. None of the other programmings are running in that. But still, I see there are some lags in the different processes. Some codes are lazy, some codes are efficient. Why it is happening?
So it's happening for many things. You know, there are some background system jobs which always keeps on running.
Yes, but our laptops or desktop, it is a computer code, it is completely all codes, 40 codes or whatever it is, that is completely free or ready to take the.
So this free, how you are telling that is free? Through some scheduler or by looking at the nodes and checking that using PS command?
Yes.
So in PS command, by looking at that one, how do you estimate that it is free? Because it's
like use a top command. Yes, not always a free, at least some percent. But I don't know what is actually those process, but it is free share of 2% is 1%, and it is 0.1%. But even that less utilization, there is difference of the parallelization. Some jobs complete faster, some jobs take so much of time to complete.
that is true. That is true. If I assume that your division of labor or work share constructs are perfect, and there is no difference in that one, then there might be two things. So as of now, we are looking at the software level. At the hardware level, the system may be slowed down. So what is happening? So since long, So you know that most of the systems nowadays is cluster, and most of them are in distributed computing way. So once the system is becoming slow, again, I do not know which system is becoming slow. Through the information exchange, I used to identify which core, or not only core, sometimes some portion of the RAM also become bad sector, and if data goes to that part, then the system or computation becomes slower. So through the communication and transaction and program execution, I identify those bad processor or bad sector. And you know that cluster I cannot switch off. Unlike to the situation in India where we don't have uninterrupted power supply, so for 24/7, sometimes we need to go for shutdown. But shutdown is a nightmare for major of the clusters because so many jobs are running. So for several days, again you have to replicate. So what is done through that one, they identify which one is bad sector or which one is a slower code. Then they isolate that one from the system by marking. So admin can mark that do not submit any further job at that particular code. And then they take it out from the cluster so that you need not have to shut down the cluster and you can also get the power.
It is maybe because of the library level.
So three different situations we will encounter for synchronization. One is the critical, which is the mutual exclusion. With diagram, I will illustrate that one. For barrier, so something we have discussed, and using diagram I mentioned that one. So if n number of threads are running, their speed is different. So if I write some barrier, then everybody will reach to that barrier, then everybody will resume their performance. That is the barrier. Now, in order to elaborate the critical part using some diagram, so let us assume that there are two cores and they are sharing three cores, and they are sharing one simple memory. And this is to occurs because of this sharing situation. If you look at the right hand side, then you see that 0 is being read by 40, it increments the value, write it back, after it write back, then core 1 is reading that value, increments and write back 2. Then after that one, core 2 is reading that one and the value at core 2 is 2. Okay. Now, although it is looking like sequential, but in parallel also it is possible that this kind of situation happens. That's why I am telling you that all the suggestions I am giving you logically is not correct. Logically is not correct. But you will see in your implementation, there is no issue. Okay. There may be the situation when core 0, core 1 and core 2 on the right hand side is executing in parallel. Okay. But their execution order is something like this. But for some reason, like one thing he has mentioned, that say core 0 is the person who is slow in computation. So if it is slow and he is supposed to read it, increment it, by that time, so core 1 has also read increments. So core 0 will write, and after that core 1 will override the same one, and it read after reading of core 0. So whatever is the value at core 2 is 1 instead of 2, and that is a mistake. That is a consistency. This situation may happen. Okay. So if this kind of situation will arise, then we have to write one critical constant. So here is the syntax. As prima OMP parallel, now I am writing critical. If I mention critical, then at a time only one has access. Now, if only one has the access, then you know that this is against the logic of parallel program. It basically enforces that serialization in my parallel program, that one at a time, one after another, it will keep on executing. Right. So for this particular example, you see what I am doing, integer x equals to 0, size equals to 12. x equals to x plus 1 printed. So x will be incremented. See their program. After that, x will be printed as 1. Right? Now, if I parallelize this code and then I set the thread size is 12. Now, as pragma OMP parallel shared x will be shared by everyone. Then x equals to x plus 1. After that, if I print, then in my system, if I go for consecutive running, sometimes I see 12, sometimes I see 10, sometimes I see 11. Now, one run can give you 12. Maybe 100 runs can give you 12, but there is a possibility it may not be 12 because of that diagram, because of that situation. Okay. So that is one inconsistency. Now, if I say that this is my critical, and if I modify this part as critical, as OMP critical, then at a time only one processor has the access to that one. That is same as writing serial code or executing that one through only one thread, but writing hash pragma OMP single or master, right? Only one. Now, how can I do that one? How can I do that means if instead of x equals to x plus some operator, after that instead of 1, there is a long expression that may happen for some scientific calculation. And my data analysis says that x plus on the right hand side, instead of 1, what expression is there, that can be parallelized. So only one situation or bottleneck is that x plus, but rest of the part can be parallelized. If it is the situation, then what you may think, try to visualize that x plus entire portion you can compute earlier, store it in some temporary variable like t equals to that expression, then you write x equals to x plus t. Right? Now what do you expect? X equals to x plus t will be sequential, but t will be parallel. Is it clear? So only one addition which is cheap in terms of the computation, even at the hardware level, which is fast, will be sequential. That is not an issue, but some complicated scientific calculation will be parallel. Right? Again, OpenMP says that, okay, so I got your idea. You need not have to rewrite this code. I have something for you, and that is your reduction cost. So it says that here, so let us assume this is your very compute intensive job, and this I can be distributed. Okay, if I assume that one, so this is only bottleneck x plus. Okay, if I compute this one earlier to this, t equals to ai multiplied with bi, then I can write x equals to x plus t, and the t computation, making t as a private, a local copy for each node, I can go for multiplying ai and bi by parallelizing for loop. Once done, sequentially, I can add this one. The same thing, you do not have to do it separately, but you can write using reduction. Hash pragma OMP for reduction plus colon x. Plus indicates the operator on which it will be sequential. X indicate what is the variable, colon is the separator, and you write x equals to x1 plus ai multiplied with bi. The same thing will be done by it. Okay? In lab, you will also see that if you use this one using critical or sequential, it will be slower compared to if you use reduction. But as this will be complex or time consuming, so good will be your analysis in parallel. But if it is very simple, like 2 multiplied with 3, something like that, then you will hardly see any difference. Okay?
Multiplication is done in parallel and addition is done in sequence.
So not all operators are capable of handling reduction. So these binary operations, addition, multiplication, subtraction, then bitwise and or not, logical and logical not. Okay. So these are supported in reduction. So only thing is that if it is not in one of them format, so you have to take it in that particular format. This one.
Yes. So I have already mentioned in reduction inside the bracket plus colon x, right? No, that's reduction.
Yes, yes. This plus you are mentioning here, and this x you are.
So my question is, as I have already mentioned plus colon x, so why should I mention the x equal to x plus again?
So here,
over format.
Yes.
Okay.
So basically, look. So what you are doing? Oh, sorry, there is a typo. There is an opening press.
Yes.
I missed that one. So this you are adding. So and as I mentioned, the biggest advantage of OpenMP is that you have to give some directive. You need not have to rewrite your code. But what you are suggesting, I have to rewrite this code. If I have to rewrite this code, then instead of using reduction, I can write that this will be my t will be my private t equals to ai multiplied with bi, and then I can do this one. Any other question here?
Yes, so can I use reduction for multiple plus multiple additions, or just one only?
At a time one.
Why not use for this plus ci times di?
Plus ci times di.
In that line.
No, for that array variable there might be some dependency. How can you do that one? So what I am talking about, the reduction is for
Cj times dj, whatever, independent. So I can't use this plus twice within a reduction statement.
no, this is, you please note, the format for this one is the situation for switch syntax. When a variable is being multiplied, subtracted, or added with itself, that kind of dependency it will have.
So I cannot use it for like j equal to x plus y plus t, or 2 plus. So I cannot use it for that.
No. For that you have to simplify everything. Okay, one last thing. Probability is there. T. Oh, okay. No, so one final thing. Okay. Then we'll move on. T. So regarding this nesting, as of now we are talking about what sharing construct. So section wise or loop wise we have done that. Right? Now the situation is if there is a nesting. So primary example is say sorting. If I go for matrix multiplication, there will be a nesting of 3, right? And if that is the situation, then it is suggested not to use this one. Okay, I will rather say it is wrong. So why I am telling this is wrong? If you do that one, it will compile, it will execute also. But I am telling wrong. Because when you are parallelizing here, you are not mentioning the number of threads. By default, how many threads will be created? Inside that one, how many number of threads will be created? So how many total number of threads are you creating? If there is a depth of 3 for, then how many? 2. So that is a combinatorial explosion of number of thread views. You should avoid that one. If you can manage, definitely you can do that one. As I mentioned, there will be no compilation error, so you can execute fine. But so my only concern is that you will write one parallel OpenMP code and report that it is slower than the serial code. So in my first course, when I was offering this one, so my colleague says, what you are teaching in class is a parallel code. My students' parallel code is slower than my serial code. So that's why several times I'm telling you should remember the number of cores. You should remember how many cores you are using out of that one. You should do program analysis, data flow analysis. Then you write appropriate code. To do this one, so again, so OpenMP suggests you to use one clause that is collapse. Collapse 2. 2 indicates depth 2. When it will be, say, matrix multiplication for then depth 3. Only condition is that they must be perfectly nested. So what we will do, so there is a concept of unrolling the loop. Unrolling the loop in one line, I can say, whatever you are writing as a loop is just for simplifying your source code. If there is no facility of loop, then also it is not a problem. Only thing is that what is inside this. So you have to write so that many number of times. But if somebody, some machine can take that responsibility on behalf of you, you are happy. So I have to write only one line of code. If you unfold that one, unroll that one, and you execute that one, I am okay with that one. I need the final result and with minimum number of lines of code. So it will unroll and see that how it can distribute the workload actively. Okay, so I am not explaining, but you can think of, say, with nesting 2 and nesting 3, that, and also it has mentioned that perfectly nested it must be. You can think, okay, so maybe you can take as today's homework that how it is working, and if it is not perfectly nested, will there be an issue or there will not be an issue?
What does the perfectly nested mean?
Perfectly nested means that no part will be outside, so everything will be inside. So there may be a situation that here for ij, after finishing this one, you are starting with for int kk equals to 0. Then ii, jj and kk is not perfectly nested. But if it is inside for int kk equals to 0, then perfectly nested and then 0. Okay. So I think I should stop here. If you have any questions, so you can ask.
So, sir, one question. The example you have just given, that the KK part is out of the nested loop. So I have to define the collapse again for collapse 1, depth 1, right?
Depth 1.
Depth 1.
Depth 1 means nothing.
No. Collapse inside the bracket 1. So I have to.
No. That is what I'm getting. Collapse 1. You think collapse 1 means a simple for loop that we can do using static and dynamic. So collapse is not required. Collapse is not required. Collapse is not required.
Collapse one is different.
Yes. Yes.
If there are any questions from online participants, please raise your hand.
Nestedly, and will mention collapse 3.
Yes. But this is your homework. You think how it is working. So you think about unrolling the loops that I mentioned. Okay, a loop can be written without loop. So by writing the same source code again and again, right? So using that concept, you try to understand.
There's one question. How alpha 30 works in the computing?
So Rijit, it seems that you are not satisfied with Asish's answer of hyperthread. Okay, go on.
This was after first.
No, this is here. So this is.
So you can ask them to raise hands. I think that is. Danny, ask them to raise hands.
This my God.
These are old questions.
This is our question. This is towards and your body is not clear. Pralay says the whiteboard is not visible. No, so raise hand.
Please raise your hands if you have any query. All online participants are requested if you have query, please raise your hands in MS Teams.
So please raise your hand. So if you have any query from the online participants. No hands. Okay. Okay, fine. So we are taking a break of 15 minutes. After that, tutorial on this OpenMP will start. So with my TS, I will also be there. If you have any question during that time, also you can raise hand. Okay.
So let me thank Professor Mitra for his short but dense talk on an OpenMP and his opinion.
Now there will be a tea break of 15 minutes. We'll assemble here at 4:50 for hands-on session on OpenMP.
Thank you, sir.
This is tea of the coffees outside. And quickly get your hardware